Good morning, gentlemen. I hope you all had a good first week of school and settled in well. And this week you will be staying at home for your HB help. Okay, let us start with chapter 7, which is on number patterns. This is your notes number 9. Okay, so let's look at the first page. We will be covering number sequences, general term of a number sequence, number patterns, and number patterns in real-world context. Now, you've already done a bit of number patterns in primary school. So, certain things are very intuitive. Like, for example, if I give you 1, 3, 5, 7, and ask you for the next two numbers, you would immediately be able to see that this is a plus 2, plus 2, plus 2, plus 2, plus 2. Okay, so you would know that, oh, the next two numbers should be 9 and 11. Or you would think that, okay, this list is asking me for all the odd numbers, so my next two numbers are 9 and 11. So it's very straightforward that way. For example, if I give you 10, 6, 2, negative 2, negative 6, what is the pattern? It is a minus 4, minus 4, minus 4, minus 4, and so on. Okay, so you can have addition, you can have subtraction, you can have multiplication, you can have division, you can have powers, etc, etc. Okay, and the numbers over here need not be whole numbers. They can be fractions, they can be decimals. So for example, I can have 20, 4, 4 over 5, and so on. So this is a division by 5, and so on. Okay, so in addition to recognizing the pattern for each sequence, we are also going to find out how to find the general term. Okay, let's turn to the first page. First page covers some definition. Introduction, you can just read on your own. Basically, there are number patterns all around us. Okay, now, what are some definitions that you need to know? Number 1, what is a number sequence? A number sequence is an ordered list of numbers. Okay, so for example, if I have 2, 6, 10, 14, 18. 2, 6, 10, 14, 18. Okay, this is a number sequence. It's an ordered list of numbers. And each number in this sequence, right? For example, the 2, the 6, the 10, all these are known as terms. Okay, so we will call them terms. And they are identified by T1, T2, T3, T4, etc. So that's first term, second term, third term, and fourth term. Okay, so in this case, this is your T1, this is your T2, T3, T4, T5, and so on. Okay, so two things you must know. This is called a sequence, a number sequence, and each of the numbers are known as terms. Okay, let's look at this first example, the basic number sequences. Okay, so if you have the first term 2, second term 6, third term 10, fourth term 14, immediately you can see that, oh, this is an addition of 4. So it's plus 4, plus 4, plus 4, plus 4, right? So what's my fifth term? It's going to be 18. So this ordered list is known as a number sequence, as we just found out. Please fill in the blanks as we go along. A number sequence, and every number is known as a term. Okay, very good. Now, if we know that T1, T2, and T3 are the first three terms, right? First term, second term, third term. If I want to know what is the nth term, okay, that will be known as Tn. So just write that down. Tn is known as the nth term, or what we call the general term. So usually the question will ask you to find the formula for the general term. Okay, so how do you do that? Now, if you know that this sequence has a common difference of plus 4. So for example, if you're looking at this sequence, right? There's plus 4, plus 4, plus 4, plus 4. What you have to do is to basically find the very, very initial term, which is the 0th term. Okay, that means what is the term before the first term? Okay, if this was a 2, that means I must take 2 minus 4, right, to get the 0th term, which is a negative 2. Correct? So once I find the 0th term, right, I can just see a pattern. Okay, let's start writing the pattern. The 0th term, also known as t0, is equals to -2. The first term is 2. The second term is 6. The third term is 10. The fourth term is 14. And the fifth term is 18. Now, what do I observe? Okay, these are all my numbers over here, the terms over here, and this is the name of the term, like T0, T1, T2, T3, T4, T5. Okay, what I want to do is to find a connection between this number here, the 0 here, and the -2. The 1 here and the 2. The 2 here and the 6. Why? Because I want to find my nth term. Okay, I want to find the Tn term eventually. So I'm trying to find a connection between this number here and the term in the sequence itself. Okay, so do you observe that, for example, for the first one, right, T0, if I take the 0 and multiply by the common difference, which is 4, and I minus 2, I will get 0 times 4 minus 2, which would actually give me the -2, right? Okay, how about the second one? If I take the 1 over here, multiplied by the common difference, and I minus 2 again, 4 minus 2, do I get 2? Yes. For the third one, T2, I take the 2, multiply by common difference, and I minus 2 again. Do I get 6? 8 minus 2 is 6, correct. Same thing here, 3 times 4 minus 2, I'll get 10. 4 times 4 minus 2, I'll get 14. 5 times 4 minus 2, I will get 18. So the 4 over here is actually the common difference. The number in front of the 4 is actually the number for the term itself. For example, for T5, I would use 5. For T4, I would use 4. And the -2, what is the -2 over here? It is actually the 0th term that we found. Okay, so it's very simple to derive the formula for general term. It would just be equals to n itself is the number here, right? And then the common difference will be the 4. So 4 times n minus 2. That's it. Okay, if the question, let's say, asks for the general term of this number sequence, you would say Tn equals to 4n minus 2. That's it. So for example, if I want to find the 6th term, the 6th term, I will just sub in n to be 6. So T6 equals to 4 times 6 minus 2, which is 24 minus 2, 22. Which is correct, right? Because 18 plus 4 is 22. Of course, for the 6th term, it's easy to use the formula, or it's easy to just add 4. But let's say I want to find the 100th term. Then I will not go and just say plus 4, plus 4, plus 4, plus 4, plus 4, 100 times, right? That's going to be very, very tedious. So instead, I will just use the general term formula. I will say, oh, T100 equals to 4 times 100 minus 2, which is 400 minus 2. You will get 398. So the formula actually helps us solve or find the number, the term, which is very, very far away. Okay, for example, the 100th term, or the 1000th term, or the 5000th term. Just because we have the formula, it's very easy to find. Okay, so in general, the general term, let me just write for you. It will be known as, okay, where can we write it? I need some space. Okay, I'm going to write it in the conclusion. General term Tn is going to be equal to the formula, right? It's going to be equal to An plus B. So what is A? A is actually the common difference. So in the example above, it was 4. And B is the 0th term. Okay, T0. Makes sense, right? So just now was 4n minus 2 because your b, your 0th term, was minus 2. Okay, so that's how you get the 4n minus 2. Please add this to your conclusion. Very good. This is pretty much what you really need to know for this chapter. Okay, so let's do practice 1. For each of the following sequences, state a rule for each sequence and write down the next 2 terms. So part A is simple. It's a common difference of minus 8, right? 80 minus 8, you get 72. 72 minus 8, you get 64. 64 minus 8, you get 56. 56 minus 8, you get 48. So, recall what you just learned. The 0th term, that means the number before the 80, right, would actually be 88. That's your 88 minus 8 will give you 80, right? Okay, and then the common difference is actually minus 8. Okay, it's not just a positive number, it's a minus 8 because it's a subtraction. So, apply formula, you will get Tn, the general term, is equals to negative 8n plus 88. Okay, or you can also write 88 minus 8n, same thing. So let's see whether this works. For the third term meaning T3, right, n is 3, I sub in into this formula, 88 minus 8 times 3, 88 minus 24, I will get 64. Is my third term 64? Yes. Okay, so just do a double check and you're done. Okay, part B. Part B is not so straightforward because this is not a simple question of common difference. Over here, you have 1, 2, 4, 8. So, I mean, immediately you can see that this is times 2. 1 times 2, you get 2. 2 times 2, you get 4. 4 times 2, you get 8. Okay, so if it's not a common difference kind of question, that means there's no plus something, plus something, plus something, or minus something, minus something, minus something. It is just a times 2, times 2, times 2, right? Then you cannot apply this formula that we just learned. Tn equals to an plus b cannot. Okay, you need to use another formula. But anyway, in this case, we just need to find the rule. That means what is how do we get the next few numbers, right? So it's times 2, times 2, times 2, and write down the next 2 terms. So the next 2 terms will be 16 and 32 because 8 times 2 is 16 and then 16 times 2 is 32. Okay, for those who are interested to find out what is actually the nth term formula for this kind of questions, it will be Tn equals to 2 to the power of n minus 1. Okay, because let's say when n is 1, T1 will be 2 to the power of 1 minus 1. 1 minus 1 is 0, 2 power 0 is 1. So the first term is 1. When n is 2, that means the second term, T2 equals to 2 power 2 minus 1. So that's 2 power 1, which is 2. And then when n is 3, you get 2 power 3 minus 1, which is 2 square, 4, and so on and so forth. So if you want to find the general term, it is still possible. It is just that you can't use the formula that we just learned. Okay? Alright, moving on to part C. Okay, by the way, if you want to try on your own first, you can just pause the video, try all these questions, and then come back. Okay? So for part C, you have 2, negative 2, 2, negative 2, 2, negative 2, right? So this one will be you minus 4 here, and then you plus 4. Minus 4, and then plus 4. Okay, so it's like an alternating kind of pattern. Or you can also do it this way. 2 times negative 1, you will get negative 2. Negative 2 times negative 1, you will get 2. 2 times negative 1 again, you will get negative 2. So, this is also a possible pattern. If you want to do division of negative 1, also can. Divide by negative 1, divide by negative 1, divide by negative 1. So anyway, following the same pattern, the next two numbers will be 2 and negative 2, obviously. Alright,